Hi, today we're going to be talking about how to balance chemical equations. Now you can think about chemical equations almost the way you can think about mathematical formula and mathematical expressions. And basically what this means is that the left side and the right side are going to be equal. Equal in chemistry is simply saying that we have this reality of atoms, and these atoms cannot appear or disappear. So the number of atoms that you start with and the number of atoms you end with have to be the same. In fact, we call this the law of conservation of matter, which says that matter can neither be created nor destroyed. So when we're looking at a chemical equation, if there's two atoms of, say, oxygen on the left, then there has to be two atoms of oxygen on the right side of the same equation. So in chemistry, we make sure of this through the process of balancing, and that's what we're going to learn about how to do today. So we're going to start by doing a practice problem. Now, this example that I'm going to use is a very straightforward one because it's a very common chemical reaction. This is the synthesis of water from molecular hydrogen and molecular oxygen. The first thing we need to do is assess the number of atoms on either side of the arrow. Remember, in a chemical equation, the arrow is essentially the equal sign, but it shows the direction in which the reaction is moving. So on the left side of the arrow, we have two hydrogen atoms. We also have two oxygen atoms. Whereas on the right side of the arrow, we have two hydrogens. However, we only have one oxygen. So let's work to balance this chemical equation. We're going to do it using some models. Now, the blue model here represents the oxygen atom, whereas the yellow ones represent the hydrogen atom. So as you can see, we start with a diatomic oxygen and a diatomic hydrogen. Now, if we combine these into water, you'll see that we have a hydrogen all fully used, but there's still an oxygen atom left over. So what we need to figure out is how we're going to balance the oxygen atom. So first thing we're going to do is we're going to double the number of oxygen atoms present at the end of the equation in the water. So we're going to put a 2 as a coefficient in front of the H2O. This is going to double the number of oxygen atoms and balance the number of oxygens on both sides of the equation. But doing this, you'll notice, now double the number of hydrogens as well, and now that is unbalanced. So what we now need to do is take the number of hydrogens on the left side of the equation and double those. That way what you'll see is we have 4 hydrogen atoms on the left, 2 oxygen atoms on the left, 4 hydrogen atoms on the right, and 2 oxygen atoms on the right. And so what this means is our equation is balanced. We start by balancing the oxygen, then we finish by balancing the hydrogen. All right? The coefficients are what are most critical in order to balance these. Remember, we're not changing any subscripts. We're only changing the coefficients in this process. So we're now going to do a second problem. This second problem might look very straightforward and simple because we're only dealing with one atom. However, there's some nuance to it. So let's take a quick look. We're going to look at the combination of oxygen molecules to create ozone. So remember, oxygen's a diatomic, O2. Ozone is a very common AP-esque molecule, O3. All right, and so when you hear about the hole in the ozone layer, that's what they're talking about. So ozone is O3, oxygen is O2. Now if we just look at the two molecules, you can see it's not balanced. But it's not quite as straightforward as just doubling one side, because if you double one side or the other, it's not going to immediately balance. So what we're going to do is we're going to look for the least common multiple. And in this case, the least common multiple between 2 and 3 is 6. So what we're going to do is we're going to try to get both sides to 6 oxygen atoms. And the way we're going to do this is by putting a 3 in front of the O2 and a 2 in front of the O3. Again, this is a fairly straightforward problem, but now it's a little bit different because, like I said, we're not simply doubling one side. We're going to have to manipulate both sides, or coefficients on both sides, to fully balance the equation. So as you can see here, now we have 6 atoms of oxygen on the left, 6 atoms of oxygen on the right, and we are fully balanced. Our third example problem, I'm going to show you in a slightly different way because it's a slightly more complex problem. Now this is the kind of the most tried and true method, so it's one that I highly recommend, especially if you're dealing with a slightly more complex problem. So what we're going to have here is sodium nitrate, NaNO3, plus chlorine gas, Cl2, reacting to yield nitrate ions, NO3-, plus sodium chloride. The first thing that I'm going to do is I'm actually going to write down the number of atoms of each type that I have on both sides of the chemical equation. So I'm going to say first is sodium. On the left side we only have one. On the right side we only have one. Then I'm going to put nitrate. We treat nitrate as a polyatomic ion as a single thing. Because it doesn't change from left side to right side of the equation, we can keep it together and actually treat it as essentially an element itself, even though we know it's not. We can treat it that way just to ease things up. That way we're not having to deal with oxygens and nitrogens. We just deal with one polyatomic ion. Nitrate on the left side, we only have one. And on the right side, we only have one. Chlorine, on the left side, we have two. And on the right side, we only have one. So you can see that because not all of these numbers match, they're not balanced. So the chlorine is the one that is specifically not balanced. So we're going to start with that. So we need to balance the chlorine. So on the right side, the first thing we're going to do is we're going to add a 2 in front of the sodium chloride. We're going to cross out the number 1 for the sodium and the number 1 for the chlorine, and we're going to replace them with 2, because remember, by putting a 2 as a coefficient, we're doubling both things. So we now have 2 sodiums and 2 chlorines on the right side. So we can see the chlorines are balanced, but the sodium is not. So what we now need to do is balance the sodium. So on the left side, we're going to put a 2 in front of the sodium nitrate. This is going to balance the sodium to now that it has 2 on both sides, but now you can see that it doubled the nitrate. So we have 2 nitrates, and we can fix that by doubling the nitrate on the right side, putting a 2 in front of it. So as you can see, what we did was we started first with the element that is unbalanced. If you have multiple elements that are unbalanced, the trick is you start with an element that's only in one reactant and one product. You want to avoid starting with the ones that are in 2 reactants or 2 products. So as you can see, our balanced chemical equation is going to be 2 sodium nitrates plus chlorine gas react to yield 2 nitrate ions, 2 sodium chlorides. Alright, now we're going to do a practice problem where I want you to give it a shot first. This chemical reaction is iron carbonate, iron 2 carbonate specifically, reacts with carbon solid to produce iron solid and carbon dioxide. So take a few seconds, pause the video, give it a shot, and when you come back, we'll solve it together. So the first thing we're going to do is we're going to write the number of atoms of each element underneath each side. So on the left side, we have 1 iron atom, 2 carbon atoms, and 3 oxygen atoms. And on the right side, we have 1 iron atom, 1 carbon atom, and 2 oxygen atoms. So the first thing we're going to look at is balancing the oxygens. We're going to balance the oxygens with the least common multiple technique, where we're going to put a 2 in front of the iron carbonate, and we're going to put a 3 in front of the carbon dioxide. This is going to balance the oxygens, but it's going to unbalance the iron. We're going to go ahead and balance by putting a 2 in front of the iron solid. Now it's nice when you have individual atoms or diatomic elements because they are going to balance last. You want to touch them last, which is why we're going to deal with the iron at the last possible step. So the iron we double on the right side, that's going to give us 2 atoms of iron on the right. And as we can see now, chemical equation at this point is fully balanced. This next practice problem, again, I want you to try it on your own. We have in this problem the combination of aluminum solid plus sulfuric acid, H2SO4, reacting to yield aluminum sulfate and hydrogen gas. So take a few seconds, try to balance this on your own. When you come back, unpause the video, and we'll solve it together. Alright, so let's solve this one together. Again, we want to write the elements underneath each chemical equation. So on the left side, we have 1 aluminum, 2 hydrogens, and 1 sulfate. Now we can use sulfate together because if you look on the left side and the right side, it stays together. It stays the same, and it never breaks up. So we can use sulfate just as a singular thing because of that fact. So we have 1 sulfate on the left. On the right side, we have 2 aluminums, 3 sulfates, and we have 2 hydrogen atoms. Okay, so this is unbalanced. The first thing we're going to do is we're going to try to balance the sulfates. So in order to do that, we put a 3 in front of the sulfuric acid on the left. This is going to balance the number of sulfate ions on the left and right side, but it's going to unbalance the hydrogens. So the next step we're going to do is on the right side, we're going to add a 3 in front of the hydrogen. This is going to balance the number of hydrogens to give us 6 on either side. This process is going to be finished by balancing the aluminum. So now on the right side, you can see that we have 2 aluminums. On the left side, we need the same. So what we're going to do is we're going to add a 2 in front of the aluminum on the left, and that's going to balance our chemical equation. So that wraps up this video. Today we learned how to balance chemical equations. And in order to balance chemical equations, remember, we have to understand that the law of conservation of matter is what's going to control the fact that atoms can't be created nor destroyed. So we need to make sure that the number of atoms as reactants are equal to the number of atoms as products. And we use balancing to do that. We did a few practice problems and a few examples. I hope that you feel more comfortable with the process of balancing. In the next video, we're going to continue this track, and we're going to have a better understanding of what these chemical reactions are and what we can use them for. Now, I'd like to thank Sammy Perizin for writing, directing, filming, and editing this video. I'll see you in the next one.